Guys, let's do the last one on this list. All right, delete leaves with a given value. Given a binary tree root, and a integer target, delete all leaf nodes with the value target. Note that once you delete a leaf node with the value target, its parent node becomes a leaf, and has the value target, it should be also be deleted. Okay. It's actually seems pretty easy conceptually. Okay, so basically we find the deepest one. Okay, conceptually it's pretty easy. Given a tree, find the target and delete all nodes that are leaves with. Find all nodes, delete all nodes that have the value of target and are leaves. Leaves are basically nodes without any parents. Not any parents, any children. So we have this unbalanced tree here. And we kept deleting all of these. Okay, so I have an idea. We definitely do have to do some DFS here. So DFS solution probably goes about something like this, right? We have root, right? So we go base case. So we have a base case. So the base case is just if not root, I guess. If the node, if basically current node is null. So base case is node is null. Recursive case. Go left, go right, and do something with current node. Okay, so one way we can what we can do is maybe do like a bubble up, right? When we go back to our parent, we can probably send a flag. We're probably gonna send a flag. Never mind. We would basically just do some kernel. So this is gonna be if target if current node value equals target and is a leaf. Delete it. Okay, so this is the idea of the thing. So that's just gonna do it once, but I have to do it over and over again. So I can repeat it. Maybe I'll do a while true. I'll do a while true, and we'll also do a flag. Keep track. Keep track of a flag, right? And for every iteration of a DFS, I'll for every iteration of a DFS, keep track of a flag. For every iteration of a DFS, if we find the target, set the flag to true, so we will keep doing it. Right? If we don't find it, we're going to set it to false. Actually, no. When can I do that, actually? So I deleted it. And if you don't find anything, okay, yeah. Basically, if you find it, keep it true. So I'm gonna keep it false. Default to false. And let's say you finished it and you couldn't find any, then I have to switch it back switch it back to true though. How could I do this? Keep track of current flag. You know, I feel like I can do this a lot cleaner instead of having like an infinite while loop. I think one way is to basically find the deepest one, right? Boom. If the current node is null, that's done. Easy bubble back up here. Okay. Now, if the current node is that, then I think it's good to bubble. I want to send something back up to the parent, you know? So what could I do with the parent? How would I tell the parent that I should be deleted? Right? Um, no, I can't do that. The problem is the deletion. I'm not sure how to delete it. Okay, let's just keep it. Let's do the brute force. Basically, find the deepest value with target equals this and delete it. And then keep doing that until there's no more twos. So let's do that. Let's keep it simple, right? So def DFS. We'll take R. Let's do if not root. Return. Let's do DFS root and return root. We'll just alter the same. Maybe I can also construct a new. Okay. Also, if like a 2 is, I assume if we're unable to, if there's a node that has the target but has children, that shouldn't be removed, right? Yeah. Okay, so DFS. Okay, we'll do go left. So DFS r dot left. DFS right. Something happened. Okay. So we'll go left, right, and then. Okay, now the current one. Actually, I'm gonna do this first. Okay, so basically we could say if cur dot right and cur dot left let's okay. Cur left right or right. I'm gonna do this first before I recurse any further down, right? Delete node. So I know I'm on the thing. Maybe I should stay one level above. Instead of recursing down so fast, let's do this. Let's assume I'm on the node right here. So I'm going to look at 3. No, I'm going to look at this guy. So let's look at the current. Okay, it's actually this. Right? If not R. So let's look at the current. Right? And I'm going to do the left child. Right child and equals to R dot left, R dot right. So we're basically looking at these two values, right? So if left child, check if it's a check if it's a leaf. So if left child and left child dot left if left child dot left and left child dot right okay, so pass, let's do and so okay, this is confusing. Let's just be fucking verbose for now. If left child, so there's actually a node to check. No. I have an actually idea. Never mind. Fuck this shit. Let's be recursive. I have another idea. So maybe instead, so DFS R dot left, R dot right, and we can just say return false, right? We'll do left, right, and we'll do this as well. If okay, so if I'm a node, if cur dot left and cur dot right, if I'm a leaf and cur dot val equals target, return true, right? So if okay, yeah. Okay, does that make sense? So if you're a leaf, return true, and then otherwise go down further. Right? So I basically go as far as I can. So I'll basically detect this one right here, right? Go all the way down, go all the way right. And then cur.val equals target. Yep. Okay, why am I saying cur? It should be R. If not, r.left and r.right and r.val equals target. Okay. Okay, so basically, let's say we go left, and then the left. We'll find basically if not R, we return false. Ooh shit. Okay, and then but we found this one, r.left, r.right. Oh no. Before I even go traverse this one, I detect it first. So this would be r.left, r.right. Yep, and r.2 equals target. Boom, we found the leaf to delete. We're gonna return true. So let's say if left, right, then we're gonna say r.left equals none. If right, r.right equals none. We self-delete it, right? Okay, there's a problem with this. I'm not doing this correctly. Hold on. So let me see if this deletes a node. So we call R, so we call 1 here. If not R, nope. So now let's check if r.left. Yep. So we don't even go to that statement. So we go left. So DFS left. Okay, boom, we're here. Let me actually do a visualization so I don't get lost. So we have 1 here, 1, right? We have 1 here. Then we have another value. 2, 3, 2, 3, 2, 3, 2, 2, 4. We check. So if not, the 1 just fails all of this, so we go left. So now we're gonna be here, and we call the thing in. Is left? Yep. So doesn't matter. Check it left, right. Nope. So that doesn't matter. So we go again. We go here. If not right. If not R. Nope. If not R. If not R.left. Yep. If not r.right, yep. Cur.val 2 equals 2, yep. So we return true here. But for this call, it returned true. With this one, r.return return false. So we do r.right. So now we've finished this. So r.right is going to equal none. So delete this guy. Okay. So r.left equals none. Okay, done. Okay, that's done. Now we have this, right? What do we return? I should return this statement. Because I want to do it again too, you know? I want to keep going up as I bubble up. And so this is false. And this equals, so we return that expression. I think that works. Hold on, this could work. Hold on, this is a nice recursion right here. Let me undo. Let me run it back. So let me see this algorithm right here. So okay, so we pass in So we pass in if not R. Yep. This nope. Is it now? Now we do if dot left dot right. That's not even worth checking. Now we go left. So we go here. So R dot right or R dot left. We go here. So we go into the thing here. So if not R, right? That doesn't pass. If not R dot left, no, there's something there. So let's go left again. So we go here. So now we do the if statement, base case. If not R, nope. If not R dot left, yes. If not R dot right, yes. And R dot val equals true. Yes, return true. Right, return true. Okay, so we return true. So we're gonna return true. So we return out. So hold on. So this return true T. Okay, here this returns false. So now we delete this node because we're gonna say our current value we're on is done. Right. We're gonna say yep, this returns that's deleted. Okay, now we finished right, so we did all of this right, so it's gonna be none. Now we finished this section, so now we're gonna check ourselves. We check ourselves and we bubble up, right? So we're gonna say okay, check. Okay, so let's do if not. So R dot left, yup, and right, yup, and R dot val equals target, yep. So we're gonna return true. So true. So we're gonna return true. Okay. Now we're gonna go to the right. So go far as right, then left. So we'll go right, then left, then we return true. I think I found it, boys. Okay, hold on. Okay, we return true. This one, I don't know what the fuck that value is. That is supposed to be a 4. That's gonna return a false, right? Then we weigh the options if left, so we're gonna delete this guy, right? And then we check ourselves. What is this? This is gonna return a false because we just finished the left and right, so it's gonna be a false. And then we basically say okay if, and then now we're at the very top of the one, so now we're bubbled back up here. We finished right for the one. Check if left. Yep, that's true. If false, yep. So we're gonna say r dot right or r dot left equals none. So we delete this guy. I think this is the recursion. This is pretty simple now. Delete everything here. True. So yeah, and then we'll get left with 1, 3, 4. Exactly how I was intended. This got to be it, bro. This is a pretty easy problem. It has to be it. Exactly, boys. Come on, give it to me. What? All right, let me see this one. 1, 1, 1, 1. Oh shit, that's a weird edge case I did not consider. So 1. This one I think I need to self-delete itself too. Hold on, I actually returned something. So, final or result. If result, return none. I think that is the yeah, easy edge case. Very simple. I love that I was able to figure out the recursion, so that was nice. Let's see what they say. Post order traversal. iterative. That's actually a super nice trick. Oh, never mind. That's actually bad then. Yeah, I think this was a pretty clean solution. Yeah. All right. See you guys tomorrow.